All right, guys, so what we're going to be starting today and what we're going to be doing today is solving radical equations. We're going to be solving these radical equations and finding the values of x. Now, kind of the first core statement or core concept that we're looking at here that's written down, two expressions are equal, then the squares are also equal. If a is equal to b, then a squared is equal to b squared. Or another way to say this is that if, let's just say x is equal to 2, if we know this is true, then x squared is equal to, well, 2 squared, which would be 4. These are the same thing. So if a equals b, then a squared equals b squared. We can square both sides of the equation, or put both sides of the equations to a power and still have the same thing. And we're going to be using this property to solve radical equations. Now, when we solve radical equations, let's have some steps. And these steps are really if we only have a radical in the equation. We have one. And our first main step is to get the radical by itself. Our first main step in solving radical equations is to get the radical by itself. That's the first main step. Now, the second step is to put both sides to the nth power. And then our last step is just going to be to solve for the variable. And we'll see how that applies and works, but it's really kind of like where we said a is equal to b, then a squared equals b squared. We can put both sides to the second power or third power, whatever we need, because that's really going to be solving or simplifying radicals. Now, if we do have more than one radical, we might have to do these steps more than one time, but these are kind of the basic steps. Because if we have two radicals, we want to get them by themselves. We'll split them apart, and we'll see that here in a minute. But these are kind of the main steps, especially if we have a single radical. So like our first equation here, the square root of x plus 5 equals 13. So this is kind of our starting equation. So when we look at this here, the square root of x plus 5 equals 13, our first kind of main step, the first thing we're going to do is we want to get the radical by itself. So the radical in this case would be the square root of x. So what can we do to get the square root of x by itself? We can subtract 5 from both sides, yes. Is 5 minus 5 will simplify, leaving us with just the square root of x equals 13 minus 5 is 8. Because the first thing we want to do is get the radical by itself. So here the radical would be the square root of x. And when we subtracted 5 from both sides, we do have the square root of x by itself, yes? There's nothing else being added to it or multiplied. So we got the radical by itself. So that finishes step 1. Step 2, put both sides to the nth power. So we're really wanting to simplify this radical, the square root. So what do I need to put the square root of x to get that radical to simplify? What power would simplify that radical? 2, because if I square a square root, the square root and square would simplify. But what I do to one side, I have to do to the other, because here the square root and square would simplify. leaving us with just x equals, well, 8 squared is 64. So the value of x is 64, and we're done. And that's it. Any questions on this here? Okay, let's look at another one. Our next one we have is that 3 minus the square root of x is equal to 0. 3 minus the square root of x is equal to 0. So really we want to solve for the value of x, so we first off need to just get the radical by itself. So what can we do to get the radical by itself? We can subtract 3 from both sides. And if we subtract 3 from both sides, well, 3 minus 3 will give us 0, so we're just left with negative square root of x is equal to negative 3. So we're going to move the number over first. Now what can we do next? Is the radical by itself? We do need to move the negative. How can we move it? Because we can multiply everything by negative 1, or we can divide everything by negative 1, because both of those will give us the same thing. Because negative 1 times negative square root of x is going to be the square root of x. Negative 3 times negative 1 would be 3. If we had divided by negative 1, we would have gotten the same thing. So we can multiply or divide by negative 1. Any questions on how we got to this here? Square root of x equals 3. Is the radical by itself? Yes. There's nothing being multiplied in front or added or subtracted to it. So that leads us to step number 2. Put both sides to the nth power. So what power are we going to use? Well, since it's square roots, since we have a square root, we're going to use the second power. Because the square root of x squared, the square root and square will cancel, leaving us with x is equal to. And that's it. Any questions on any of this here? Okay. Square root of x equals 6. What would the value of x be? Because here, the square root of x is already by itself, yes? There's nothing added or subtracted to it. So what we can do is we can square both sides. And well, the square root and square would cancel. And 6 squared is 36. So here we would just square root both sides. What I need to include the plus and minus for this here? Because 6 squared is 36, and negative 6 squared would be 36 as well, yes? Well, square root of 36 is 6, yes? What is the square root of negative 36? Well, that's not what we want, right? So we wouldn't include the plus and minus, it would just be 36. So if we're squaring both sides or putting both sides to a power, we don't take the negative and positive case. But if we were going the other direction and square rooting both sides, then we have the plus and minus. Because here, we're undoing a square root. When we square root both sides, we're undoing a second power. That is the main difference. So for these here, where we're just trying to find the square roots, we don't have to include the positive or negative case.
At first
Yeah. Yeah, so if it had been this setup here to start with, and then we square root both sides, then x would be plus or minus 6. But because we're squaring, we don't have the positive negative case. Do we feel comfortable with these here? Yes? We're going to jump ahead to this one here. It should be the first one with example 2 written at the top or above the problem. Now, these here are going to be similar to the ones we skipped. It's just adding a few steps. Because, again, we do have one radical, yes? Okay, step number 1 is to do what? Get the radical by itself. So, yes, I would subtract 3. So the first thing we really need to do with this here is to get the radical by itself. So the first step to get the radical by itself is we can subtract 3 from both sides. Because positive 3 minus 3 would be 0, giving us 4 times the square root of x plus 2 equals, well, we do 19 minus 3, which would be 16. So again, the first thing we need to do in solving these radical equations is to get the radical by itself, get the square root by itself. So we can subtract 3 from both sides, and we get 4 times the square root of x plus 2 equals 16. What can we do next? Divide by 4. Because we want to get the radical by itself. Because here, 4 divided by 4 would be 1, leaving us with the square root of x plus 2 equals, well, we'll do 16 divided by 4, which is 4. Okay. So we subtracted 3 first, and then we divided by 4. So what would we do next? So what's the main goal? The main goal is to do what? To get the radical by itself, yes? Is there anything with the radical? No. I mean, we have the x plus 2, right? But the x plus 2 it's inside the radical, yes? So when we look outside the radical, there's nothing left being added or subtracted to it. There's nothing being multiplied out front. So there's nothing out front being multiplied. There's nothing added or subtracted behind it or in front of it. We don't have anything else besides that radical, correct? So we got the radical by itself. It's very tempting to say because of that minus 2, or the plus 2 inside, we can subtract it. But because it's inside the radical, we're not going to worry about it yet. We have gotten the radical by itself, which means we can move on to step number 2. So we can put both sides to the what? Second power, because we have a square root. As the index or the nth root of this is a 2, it's a square root. So to undo a square root, we square both sides. The square root and square would simplify and leave us with x plus 2 equals 16. Well, now we can solve. Because at this point here, on most of the ones we've done so far, we squared both sides and we had our answer. Here we need to do one more step. We need to subtract 2. Which it tells us x is equal to 13. And that's our answer. And on any of these here, if we wanted to check them, we can. We can take 14 and plug it back into the original equation. and see that, yes, it does give us what we want. Any questions on any of this here? You ready for another one? Yes? All right, let's look at this one here. 3 times the square root of x plus 5 minus 1 is equal to 11. So our first main goal is to get the radical by itself. That's what we want to do first. So what's the first thing we can do in getting the radical by itself? We can add 1. Because it's going to be easier to add or subtract first. Because our negative 1 plus 1 will simplify out, leaving us with 3 times the square root of x plus 5 is equal to 11 plus 1 is 12. So we move that over first. Is there anything else we need to move, or we need to divide by 3? Because we have 3 times the square root of x plus 5. So to get the radical, the square root of x plus 5 by itself, we need to divide both sides by 3. So our 3 divided by 3 will simplify to 1, leaving us with just the square root of x plus 5 is equal to 12 divided by 3 is 4. Any questions on how we got to this here? The square root of x plus 5 equals 4. Well, what can we do next? Oh, square, yes. We want to square both sides. Because when we square the square root and square will cancel out, leaving us with just x plus 5 equals, well, 4 squared is 16. Because we get the radical by itself so that we can square both sides or put both sides to whatever the root is, and to get it to cancel. Now we have x plus 5 equals 16, so we do need to finish solving this by subtracting 5 from both sides, because 5 minus 5 would give us x by itself. And 16 minus 5 is 11. And that's our answer. Any questions on any of this here so far? Are we good with all of this here? Yes? Do we need to see another example of one of these here? We're good with these here? Okay. Because if you end up having questions once you get started working on these, please ask. Please ask. We can go over them. I can go over them with you. All right, example 3. Solve an equation with radicals on both sides. Now, whenever we have more than one radical on any side of the equation, when we have 2, we want to get them on either side. 1 on either side. Now, if we have 3, it's pretty much dealer's choice. You're going to get 2 and 1. Or 2 and 2. You try to split them up so there's an even number on either side. And once we get them kind of split up, 2 and 1 or 1 and 1, we put both sides to the index of the radicals. So we look at this here, well, we have a square root and a square root, yes? So if I wanted to get one of these radicals to simplify, well, for the one on the left, I can put it to the second power, the one on the right. I could square both sides. Now, if we square both sides, well, the radical and the square would cancel. The one on the right, the radical and the square would cancel. And this works really well when we just have a radical on either side, because the radical and the square would cancel. Here, the radical and the square would cancel, leaving us with 2x minus 1 is equal to x plus 4. Because when I have one radical on either side, I can square both sides of the equation, and the radicals go away. Well, now that's all that's left is solving for the value of x. So what can we do next? All right, we'll move x to one side and everything else to the other. So we don't have to set it all equal to 0, move everything to the same side, because the biggest exponent is 1. We don't have a square, we don't have a quadratic. So what we could do is I can add 1 to both sides. Our negative 1 plus 1 would cancel, giving me 2x equals x plus 5, because 4 plus 1 would give us 5. Now we can get all the x's on the same side. And we can do that by subtracting an x from both sides, because x minus x, this would cancel out, giving me 0. 0 x's on that side, so I just have 5. And 2x minus x would be x. So really, if I have two radicals, nothing else, just two radicals, I can get one on either side, square them, solve for the value of x. Any questions on this here? The next one. Come on. There we go. So here we have the square root of 4x minus 3 equals the square root of x plus 9. So in this equation here, we do have two radicals. And since we have two radicals, we want to get one on each side of the equal sign. And we do already have that from the start. We have the square root of 4x minus 3 is equal to the square root of x plus 9. We already have it set up the way we want, yes? So what can we do? We can do what to both sides? We can square them, yes. We can multiply them by themselves. We're going to square both sides. And this works out really nicely because, again, we only have a radical, one term on each side of the equal sign. So it'll be nice, and these will cancel out. And what this will give us is 4x minus 3 on the left-hand side is equal to x plus 9 on the right-hand side. Any questions on this here? All right, what can we do next? We can add 3 to both sides. Because our negative 3 plus 3 will simplify, giving us 4x is equal to x plus 12. And I would subtract x from both sides. 4x minus x would give us 3x equals, well, x minus x is 0. Left with 12. And last but not least, we would divide by 3, telling us that x is equal to 4. So once we squared both sides, we can use our multi-steps to solve using addition, subtraction, multiplication, and division. Any questions on any of these here so far? Okay, well, looking at this here, we do have two radicals, but they're not on the same side of the, well, they're both on the same side of the equal sign. So what do I need to do here so that we can be able to solve? What do we need to do? They need to be on what? They need to be on opposite sides of the equal sign, because anytime we have two radicals, we need them on opposite sides of the equal sign. No matter what else is with the equation, we want these radicals split. So what I could do is, well, I could add the square root of 4x minus 7 to both sides. I can add that whole term to both sides. Because these two here will cancel out. And it'll leave us with the square root of 3x plus 1 on the left-hand side. And on the right-hand side, we'll have the square root of 4x minus 7. We can add or subtract, just like with numbers, to both sides with these radicals. And by doing that there, we get the square root of 3x plus 1 is equal to the square root of 4x minus 7. Any questions on any of this here so far? We good with this here? Okay, so what can we do next? We can square both sides, just like we did with the last one. Since they're both square roots, it works out nicely that squaring both sides will simplify these radicals. The square would cancel, square would cancel, bless you. And what we're left with is 3x plus 1 is equal to 4x minus 7. So what would we want to do next? We can subtract 1 from both sides, yes. And we subtract 1 from both sides, 1 minus 1 would give us 0. And we would have 3x is equal to 4x minus 8. So the first thing we can do is we can subtract 1 from both sides. Then what can we do next? And we can subtract 4x from both sides, yes. Because our 4x minus 4x would give us 0. And 3x minus 4x would be negative x is equal to negative 8. Yes, we need to multiply both sides by negative 1. Because we do need the value of x to be positive. We get x is equal to 8. We could have also divided by negative 1, and that would have given us the same thing. Any questions on any of this here? Any questions on anything we've done so far? Now, probably the big question is, so this here, that's the same, is looking at example 4. Solve the cubed root of 5x minus 2 equals 12. So what can we do first? Because it seems like it'd be a lot harder, doesn't it? Because we're dealing with...
Just multiply by 3.
Because the cubed root of 5x minus 2 is still a radical, isn't it? Okay. Is it by itself? Yes. So that takes care of step 1. Step 2 is to put both sides to the nth power, yes? So we wouldn't put both sides to the second power. We're going to put both sides to the third. Because the cubed root n cubed will simplify, leaving us with 5x minus 2 is equal to so now we're just cubing both sides. So we have to cube 12, which gave us 1,728. And the cubed root of 5x minus 2 cubed is 5x minus 2. Now we just need to solve for the value of x. We can add 2. Because negative 2 plus 2 would simplify, giving us 5x is equal to 1,730. And then we would divide both sides by 5. And that's it. So with these cubed roots, it's not any different than what we did with the square root, except we're having to cube both sides instead of square it. Any other questions on these here?